Welcome to StartupHakk, where we love training software developers. We take people with zero experience and help train them to be ready to start as a full-stack software developer in as little as 3 months. So we talked with a lot of people. They don't understand how ChatGPT and other AI tools are working. At the core of AI are LLMs, which stands for large language models. These are the core of how AI works. So let's talk about how LLMs work today. The inner workings of LLMs are complicated. Even researchers don't fully understand how the models work, but it's helpful to have a basic understanding of what happens when you use ChatGPT. So these are large language models. So let's start talking about language. So human represents words with letters. For instance, CAT spells cat. Language models represent words with numbers. A lot of numbers. These are called word vectors. And here's one way to represent cat or CAT as a vector. This is what a vector looks like to a computer. Words are complex, and language models store each specific word in a word space, a plane with the dimensions that the human brain can envision. It helps me to picture a 3-dimensional plane to get a sense of how many different points exist within that plane. Now, add a 4th, 5th, and 6th dimension. You can envision each word stored as a vector in this plane. Language models store words in clusters, with similar words placed closer together. For instance, the word vectors closest to cat include dog, kitten, and pet. Here are other examples of clusters. The language model determines vectors placements and clusters based on a neural network that's been trained on heaps and heaps of language. The neural network gets really good at knowing that often dogs and cats occur together, that walk and run are similar in meaning, or that Trump often follows Donald. In these clustered words together, it then clusters those words together. Vectors add as good building blocks for language models because they can capture subtle, important information about the relationship between these words. If a language model learns something about a cat, for example, it sometimes goes to the vet. The same thing is likely to be true of a kitten or a dog. If a model learns something about the relationship from Paris and France, for example, they share a language, there's a good chance that the same will be true for Berlin and Germany, and for Rome and Italy. A newly created language model won't be very good at this. It might struggle to finish the sentence, "I like my drink with cream but more and more training, the model improves. Eventually the model will become good at predicting sugar as the word that should finish the sentence. For humans, this comes intuitively. For language models, this happens with a lot of math in the background and a lot of learning on the languages. The key to this is scale. GPT-3 was trained on nearly the entire internet. Books, articles, Wikipedia. The model was trained on about 500 billion words. By comparison, a human child has absorbed about 100 million words by the age of 10. So that's a 5,000 times multiple on the language digested by a 10-year-old. Now, one downside of training the data, because large language models have been trained on human content, they inherit human biases. In word vector models, for instance, associations between female and medicine may be more likely to produce the noun nurse, while associations between male and medicine may produce the noun doctor. Researchers are working to mitigate human bias that have crept into AI. So what's complex about language is that it's full of nuances. Computers were originally built for computation, hence the name computer, which is more straightforward. 2 + 2 always equals 4. But words can have many different meanings. I like these examples. The customer asked the mechanic to fix his car. Does his refer to the customer or to the mechanic? In the professor urged the student to do her homework, does her refer to the professor or to the student? In fruit flies like a banana, is flies a verb referring to fruit soaring across the sky, or a noun referring to banana-loving insects? This is tough. The model needs to understand the context around each word. To use an example, interest in this sentence has 2 meanings. In the first use, the other words in the word cluster might include enthusiasm and encouragement. In the latter use, related words might include profit and dividends. How does the model know which meaning of interest is intended for this one? For that, we need to talk about transformer models. A transformer is a type of architecture for the neural network. You can think of it as a series of layers. Each layer of the model synthesizes some data from the input, storing that data within a new vector, which are called hidden states. Those new vectors are then passed to the next layer in the stack. To vastly oversimplify, take a few examples for the above sentence. The first layer of the stack might mark I and bank as nouns. The next layer of the stack might notice that I and know and in are all related to the first use of interest, thus recognizing that the words in this sentence mean something close to enthusiasm. A third layer might then note that the second interest relates to bank, deducing that it is a financial in nature and that bank means financial institution, not a riverbank, and so on. You can see how this can get complex really quick. Simply put, each layer of the transformer gets smarter and better at grasping the sentence meaning and its nuances. The first few layers tend to focus on understanding a sentence's syntax and resolving any ambiguities, interest versus interest, for example. Then later layers tackle a more holistic understanding of a passage's meaning. Of course, the real thing is much more complex. The most powerful version of GPT-3 has 96 layers, and naturally, word vectors are much more complicated than we can show you here. The most powerful version of GPT-3 uses word vectors with 12,288 numbers. Again, things have improved fast. GPT-1 was released in 2018 and had 12 layers and 768 numbers in word vectors. Those 12,288 numbers, called dimensions, become important for complex inputs. As LLM digests a long written work, it continues to adapt word vectors to add more and more information and context. If I'm the main character of the story, for instance, the model may shift the rex vector in each layer of the transformation to contain more and more information. So that's the crux of how LLMs work. They translate words to lots of numbers, then adapt those numbers in each level of the stack to understand context and meaning. So what's cool is how good these models have become at quite nuanced language concepts. Scientists at Redwood Research studied GPT-2 to see how it would finish the sentence, when Mary and John went to the store, John gave a drink to blank. The model was able to fill in the blank with Mary, and further investigation by researchers showed that the model had used a subject inhibition attention ahead to block John from being used again. Put more simply, the model recognized that it wouldn't make sense for John to give a drink to John, so it blocked him and looked for another potential subject in the sentence. Of course, language is complex. If the sentence were John and Mary arrived at the restaurant and John gave his keys to blank, the logical word wouldn't be Mary, but the valet. Humans know this, but the valet isn't mentioned anywhere in the sentence. Still, ChatGPT nails this challenge. Not bad. The model likely uses give, restaurant, and keys as contextual clues to answer the question. LLMs are much more complex than this short summary lets on. The goal here was to compare a high-level understanding of how LLMs train on vast amounts of data, then perform a series of complex, rapid calculations to translate inputs into outputs. For more in-depth analysis, check out more information on the internet, and you can definitely Google around and learn a lot more. So that gives you a bit of what LLMs are, which are what drive AI and this new AI revolution. Here at StartupHakk, we love training software developers. We take people with zero experience and help train them to be ready to start as full-stack software developers in as little as 3 months. So make sure to check out the link down below or go to startuphakk.com and get started today.